speakers, we have Azul Hafiz, Marham, Amy, Ayuni Farida, Muhammad Haziq, and Nabil Najwan. So starting with introduction. So what is material degradation? Material degradation is deterioration of materials over time due to experimental exposure, mechanical stress, and chemical reaction. There are common forms of material degradation, which is corrosion, wear, erosion, and fatigue. Most of these common forms, the corrosion is one of the most significant problems in industrial areas. Gebeng is a major industrial hub in Pahang. The area experiences high humidity, subleaded air, industrial emission, and chemical contamination. These conditions accelerate material deterioration and can reduce the service life of industrial equipment and infrastructure. Next, I would like to pass to the next presenter.
Next is about the type of material chosen. So, the fundamental driver for our selection material process the environment at Gebeng Industrial Estate. We are dealing with the coastal area atmosphere and also with aggressive petrochemical environment. So for the material, traditionally the facility use standard carbon steel, which is ASTM A36 as their piping and support structure, and also the standard concrete grade 30 for their foundation. So the standard carbon steel, the type is structure, and the function is to load bearing column, piping system, and also used for equipment support. For the concrete, the function is for the foundation structure, column, and also the use for floor slab. So based on these two materials, the relation to failure, the carbon steel is reduced cross section and also loss capacity and sudden brittle failure. And also the standard concrete, the relation to failure is failing, rebar corrosion, and also sudden collapse. So the upgrade material, to ensure that the material can last long and can use for a very long time period, we have moved to the upgrade material from the standard carbon steel to the aesthetic stainless steel, which is 316L grade for all critical components such as piping system, equipment support, and also load bearing column, which is the improvement that we get from the upgrade system, upgrade material. There is no corrosion related structure failure expected within design, and also high ductility and yield strength prevents sudden brittle fracture under heavy load, and also it's maintain structure integrity even in harsh coastal and petrochemical environment, which is the Gebeng industrial main industry. And from the standard concrete grade 30, we are also upgrade to the high performance concrete HPC, which is the replacement for the structure column, floor slab, and also the containment structure. So the advantage from the previous material is it increase density and provide a superior barrier against chemical penetration, protecting the internal reinforcement and also ensuring the structure skeleton of our facility and remain intact for decades to come. So the next part.
So after that, we move to the physical properties of the materials. So as for the original material, we use grade 30 concrete, which is a porous cementite matrix. It is also a weak interfacial transition zone, and it has a high permeability to moisture and lead to external expansion and spreading. So basically, a grade 30 concrete acts as a hard sponge, which is it absorbs the chemical in the environment of the Gebeng industry. So to solve the problem, we move to the high performance concrete, which also called as HPC. It is a very fine and dense microstructure. It has tight IPZ with far less capillary holes. It's a very low permeability, physically blocked, chemical attack, superior compressive strength. So the HPC has a more compact structure which avoid the chemical to absorb in the concrete. So next we move to the standard carbon. We move to the steel material. The original material is a standard carbon steel, which is a ferrite pellet structure and no intrinsic specificity to attacks. It has highly susceptibility to uniform and pitting corrosion, reduces effective cross section, lowers yield strength and tensile capacity. So standard carbon steel has has no protective shield from the chemical at the Gebeng industry, so it will rust and slowly move into crack. And next one, the upgraded material is a stainless steel 316L. So it has a fast centric cubic FCC crystal structure enriched with molybdenum. So molybdenum act as the material protective shield for the from the environment at the Gebeng environment. So it has continuous ultra thin passive chromium oxide layer. It has a nano scale barrier, physically prohibit chloride penetration, which is also good to avoid any the steel from rust. And yes, it has excellent ductility and high yield strength, since the Gebeng industry need to use the high ductility steel.
For the number 4, the mechanical properties, microstructures of the materials and engineering solutions. The properties and microstructures have been presented by Azu at the chapter 3. So for the engineering solutions, the carbon steel must be replaced with 316L stainless steel to use the protective coatings and corrosion control systems, where replacement is impractical. For the grade 30 normal concrete, must be replaced with HPC using supplementary cementitious materials to reduce porosity and also the permeability. So for the 316L stainless steel, we use for exposed structural members, pipelines, and also the equipment in chloride-rich industrial zones. For the high performance concrete HPC, used for foundations, columns, floor slabs, and containment structures exposed to aggressive environments.
Involves casting, hot rolling, cold looking, solution cleaning, and welding. And after doing those processes, it will produce a uniform austenitic microstructure. And it will also maintain the passive chromium oxide layer. And by maintaining the passive chromium oxide layer, it will provide us with an excellent corrosion resistance material. As for the high performance concrete, HPC, the processes include careful material selection and then followed by using a low water cement ratio. After that, it will be adding of supplementary materials such as silica fume or fly ash. And lastly, it will be followed by proper mixing, then casting, and then curing. By doing all these processes, it will produce a dense and low porosity structure, which is suitable to be used for an industrial area which is as corrosive as the Gebeng industrial area. 5.2 application of the materials. As for the 316L stainless steel, which will be replacing the normal stainless steel, it will be used for the pipeline, storage tanks, pressure vessels, and equipment supports that will be exposed to the corrosion at the industrial area, since this material has excellent corrosion resistance, high strength and ductility, which will contribute to a long-term service. And for the high performance concrete, which will be replacing the grade 30 concrete, will be used for the foundations, columns, floor slabs and containment structures at the area. Since it has high compressive strength, low permeability and has a good resistance to chemical attack, so both of these, by combining both of these materials, it can lead to a longer term service and also a safer and more environmental friendly area at the Gebang industrial area.
So for conclusion, information metal degradation is primarily driven by environmental and chemical exposure, leading to significant deterioration of industrial equipment and infrastructure. So here are our key findings, where corrosion is the dominant degradation type, which high humidity accelerates material deterioration, and industrial emission contribute to degradation, and it increase maintenance and replacement costs. Therefore, proper monitoring, maintenance and material selection are essential to minimize degradation and extend the lifespan of industrial assets. That's all from us. Thank you.